Pydantic AI establishes a type-safe foundation for providing external services to an agent by separating the static dependency type definition from the runtime instance injection. By defining a data class to hold an API key and an asynchronous HTTP client, we will configure the agent constructor with a deps type constraint before executing an asynchronous run that injects the concrete deps instance to retrieve the model's output. From data classes, import data class. Import HTTPX. From Pydantic AI, import agent. At data class. Class MyDeps, hash 1. API key, SDR. HTTP client, HTTPX, async client. Agent equals agent. OpenAI, GPT-5 Deps type equals MyDeps, hash 2. Async def main. Async with HTTPX. Async client as client. Deps equals MyDeps foobar, client. Result equals await agent.run. Tell me a joke. Deps equals deps, hash 3. Print result, output. Did you hear about the toothpaste scandal? They called it Colgate. This code demonstrates the foundational dependency injection pattern in Pydantic AI, using a standard Python data class to manage external services and configuration. By defining MyDeps and passing it to the agent constructor via the deps type parameter, we establish a strict type contract for the execution context. During runtime, an actual instance of this data class is passed to the deps parameter of agent.run, ensuring that the agent execution environment has type-safe access to the required HTTP client and API key. The execution yields a result where the output attribute contains the final response from the model. Leveraging explicit dependency injection rather than relying on global state provides significant advantages for production applications. It allows static type checkers to verify that the correct dependencies are provided before the code ever runs, which prevents costly runtime errors. Furthermore, this architecture drastically simplifies testing, as developers can easily mock or swap out the network client by passing a different dependency instance during test execution. Let's break it down. From data classes, import data class. Import HTTPX. Imports the data class decorator from the standard library to define data-centric classes, along with the HTTPX library for making HTTP requests. At data class. Class MyDeps, hash 1. Defines a Python data class named MyDeps. This creates a structured container used to define the type and shape of custom dependencies that will be passed into a Pydantic AI agent at runtime. API key, SDR. HTTP client, HTTPX, async client. Defines two typed attributes. The API key is specified as a standard string, while HTTP client is typed as an asynchronous HTTP client from the HTTPX library. Agent equals agent. OpenAI, GPT-5 initializes a new Pydantic AI agent instance and assigns it to the agent variable. The constructor receives a string identifier specifying OpenAI's GPT-5 as the default language model for this specific instance. Async def main. Defines the main asynchronous function that serves as the primary entry point for execution. Async with HTTPX, async client as client. Initializes an asynchronous HTTP client within a context manager, assigning the instance to the variable client. This ensures network resources and connections are automatically cleaned up when the block finishes executing. Deps equals MyDeps foobar, client. instantiates the MyDeps class with a string identifier and a client object, assigning the result to the deps variable to provide runtime dependencies for an agent execution.
Result equals await agent.run. Tell me a joke.
Asynchronously executes the agent by calling its run method with the text prompt asking for a joke. The execution pauses until the agent completes its response, assigning the final output object to the result variable.
Print result, output. Did you hear about the toothpaste scandal? They called it Colgate.
Prints the final response stored in the results output attribute to the console. The comment demonstrates the expected plain text string returned by the agent. Decoupling the static type contract from runtime execution transforms agent dependency management into a predictable, type-safe pattern. The custom data class acts as the exact bridge between initialization and execution. Binding the type constraint at the constructor level establishes a rigid boundary that static analyzers enforce before any code runs. Later, injecting the concrete instance during the asynchronous run call gives the agent safe access to live network resources. Because the execution context is guaranteed to match the expected shape, you eliminate entire classes of runtime errors while making it trivial to swap out the HTTP client for isolated testing.
The agent that studies a deps-type silhouette must grasp a living deps instance to begin the run.